All right, it looks like we are live, testing everything. Looks like it's good. Alrighty then, welcome to another live chat for December 6th, 2023. Make sure everything is up and running. Looks like we're all good. I think you should pre-chat music. I don't know how to pull that off. Is there a way to pull that off? I'm not sure if there's a way to pull that off. I will investigate that. I don't know. We have a lot to talk about, though, tonight, as there is so much going on right now. It may not seem like it, but there really is. A lot going on in the atmosphere. A lot of changes are starting to evolve, and the model guidance is starting to pick up on those changes, which is very, very interesting. So I was thinking about, okay, where should I start? Should I start with the developing stratospheric warming, the shifting tropical forcing? Obviously, I'm going to be taking all of your questions, and we'll definitely cover all of that. And of course, we'll answer all the questions first on the premium chat, and then I'll take the best questions out of YouTube and, of course, on X. So definitely get your questions out there, so we'll definitely answer them. So I guess we'll start off with the data. And again, we understand where we are right now, right? Where the winter forecast is out, it's been out, and really everything that I've been looking at, everything that I was studying back in September and October, the thoughts I had with this pattern has really started to evolve almost perfectly, which, when it comes to a long-range forecast, it's somewhat surprising because you have a general idea, but you don't think things are going to fall into place like dominoes. But this certainly is, in many ways, very, very interesting how the pattern has been evolving. And overall, if there's any adjustments I'd make, is maybe a little colder than what I thought, and I'll explain why in just a moment. Of course, premium members already saw the long-range chat, why I think that this forecast may end up being a bit colder. But let's take a look at the observations. There we go. This is the observations. This is no longer, hey, model guidance, 10 days out, 15 days out, maybe stratospheric warming. It's starting to take place right now. And you can see the building of our warm anomalies starting to shift towards Canada, just as forecasted. And you're seeing the slow disruption of the polar vortex starting to take shape. Right now, it's pretty much average for this time of year. But it's starting to take place. It's starting to take hold. And the reason why this is important is that this is no longer a long-range forecast. It's not even a medium-range forecast. It's verifying right now. So the fact that this is verifying right now puts you in a different arena in terms of winter forecasting, because it's no longer a situation of, hey, I wonder what's going to happen, or how will the tropical forcing interact with the negative QBO. We're seeing it right here. It's right in front of us. So now that we understand the laws of the atmosphere, and we understand, based on all of our education and what we've been studying for months on end, we understand why this is important. It's important because it kickstarts everything in terms of the disruption of the polar vortex, and allows for us to develop our high latitude blocking. This also leads to much stronger support for those seasonal models like the CFS and the European 45-day forecast and the monthly forecast that have been producing very, very impressive long-range forecasts for January and February for winter storm potential. It's been showing this since, the summer? And I'd say going back to July, we've been seeing hints, and those hints have been getting stronger and stronger. And what I'm going to show you tonight is the updated version, and we'll just talk about what the guidance is shown and what it means in just a few moments. So there's our observations, and if you really want to dive in, this is the cpc.ncep.noaa.gov under Stratosphere. So if you go to the main page, go to Stratospheric Home, and then Global Temperature Series. This is all free, of course, and you could dive in and you could see the temperature evolution. We can zoom in here. This is at 100 millibars. Let's jump to 50 millibars. There's our jump starting to show up. And then 10 millibars. And there's our strong stratospheric warming right there. Now, why did I go to each level like this? The reason why is that you want to see this trend taking place at all levels of the stratosphere. Sometimes when we have major stratospheric warming at 10 millibars, it kind of runs into a cap and doesn't get down to 50 millibars and 100 millibars and then the troposphere, which means you have disruption in the upper portions of the stratosphere but not the lower. In this case, you don't have anything like that worrying about because we just checked from 100 millibars up to 10 millibars. We're starting to see that rise in temperatures. And we're getting to the point now where we're getting into record levels of stratospheric warming. So what you want to do, you want to basically get this red line into these areas here. It doesn't always have to get to the top of the chart. I mean, this is record-breaking temperatures up here. Okay, this is about where your average. And notice as we get into the winter months, that average gets a lot wider because you get a lot more volatility in the winter in the stratosphere. Okay, because you have cold spots and warm spots because you're not getting direct sunlight, so there's not getting even heating. So you get more influence from things like the EP flux and stuff like that. So what we're seeing here is clearly well above normal temperatures. And again, we're walking through this because we have to understand the observations. Because if all you're doing is looking at models, then you're just going to be blind if there is any type of error. So again, we got 10 millibars. We got 50 millibars rising starting. We're going from below normal to near normal at 50 millibars and well underway rising. And at 100 millibars, it's starting that process. And literally, if you look at each level, it's basically a carbon copy of how that warming started. The cooling stopped just completely stopped and then it started rising. And that's what we're seeing at each level. So you're seeing that evolution take place very nicely here. And it matches up very nicely as well to the model guidance when you go out 24 hours. So about 24 hours, very well forecasted. So then we could trust this forecast going forward. Going 5 days out, you see that stratospheric warming maturing. And what's important now is that instead of that warming just remaining over northern Canada, and there was some of that concern that, hey, look, if we have that warming just focused over northern Canada, let me refresh this real fast. If you have that warming just focused over northern Canada, then the polar vortex is going to be focused more towards Europe. But now, with agreement from the European and the GFS and GFS ensemble guys, we're also seeing that warming taking place from Asia and spreading across like this. This makes more sense considering how cold the air masses are getting in Siberia. And also the fact that the tropical forcing is going to be returning into phase 8 and 1 as we head towards this time period. So this all combines very nicely into the forecast that we're seeing now, where our polar vortex starts to stretch back towards North America. And we start to see that split. And the GFS is producing the same thing. So we are seeing clear disruption of the polar vortex, increases the potential for a high latitude blocking, and that matches up very nicely to the forecast we've been seeing here. For those of you who don't know, This is from the directly from the European website. Okay, you go to charts.ecmwf, or you could just Google ECMWF and just go right to these charts. They're all totally free. And what's important here, you see this red line here? Let me zoom in. This red line represents average. We've been steadily below average, and then we tank. So this has been a consistent forecast for weeks now. Actually, literally months. The GFS was not on board with this for quite some time, but now it has kind of got on board along with the European ensemble guidance. And what this is showing is that once you get below this line here, this is a major stratospheric warming potential and for early January. And this has been growing in support steadily. And when you think about what's evolving here, the tropical forcing, the EP flux growing, the evolution of the disruption of the polar vortex, and the support for a high latitude blocking from Scandinavia to Greenland, all of that all points to a solution where we have a major stratospheric warming event and a significant disruption of the polar vortex. So what I'm trying to show you here is all the data is moving in one direction. Now, what could disrupt this? I don't see this as far as any type of indication of the polar vortex strengthening or becoming strong or anything of that nature. At least not to the spring. There's just far too much going on for that to happen. But there is a chance that we could see a slowing down of the weakening. That is a possibility. Or that the way that the polar vortex gets disrupted, maybe the lowest 500 millibar height shift more towards, let's say, Eastern Asia or something of that nature. Could that happen? Absolutely. So we're going to have to watch to see how the high latitude blocking in the troposphere evolves. But right now, based on everything I'm seeing, well, snow lovers are going to be pretty happy based on what I'm about to show you guys in a few minutes. Finally, this is the another way of looking at the tropical forcing. Okay, this is the European ensemble's 200 millibar vertical velocity. Okay, velocity potential, and think of this as where you have this shading, you're getting the strongest lifting, and your strongest lifting supports the evolution of more convection, and then the more convection you see at the dateline, you know what that means. So right now we're kind of moving around that phase 3, 4, 5, 6, 7, right? We've been talking about that where we get this mild pattern in place. But even with it being mild, we're getting these cold shots coming in from time to time. But it's a very progressive pattern, right? Even with that, with the less than favorable MJO environment, you still got a lot of convection around the dateline. A lot of thunderstorms developing. You're still seeing that taking place. And as we move towards the end of the month, we see that shift for more favorable forcing lining up. So again, this all continues to fall into place. Along with our El Nino, as you know, which we already went over. So when I look at everything that's happening here, I take a look at the 850 millibar air masses. And one of the things I was really concerned about with the winter forecast was, hey, with the snowpack having a little bit of a difficulty growing in Siberia in mid-October, what will be the state of the air masses that we're going to be working with? Are they going to be marginal? Are they going to be very progressive moving? Will the cold air masses give way very easily? And what we've been seeing over the past couple of weeks is a rapid intensification of our polar and Arctic air masses across Asia and now bleeding into North America. Now, the influence of our current pattern obviously is driving Pacific air into portions of southern Canada and, of course, the United States. And even with that, the air masses that drop in, notice they've been pretty dry and they've been pretty strong. And they haven't exactly been easy to get out of here, right? They've been putting up a bit of more of a fight than what some of the model guidance has been suggesting. And we now have very impressive polar and Arctic air masses building in our source regions. So now it's no longer a question of will we have polar and Arctic air masses to work with? We will. Now it just comes down to how will all these ingredients come together when the pattern is favorable. That's pretty much where we're at this point. It's no longer at a situation where we have to wait, we have to figure out, we have to wait for disruption, we have to wait for tropical forcing or El Nino to shift or anything like that. Those factors are already taken care of. The overall theme of this pattern is where we want it to be if you are a winter weather lover. The question now, and as I always say with every winter, you have all the ingredients ready to go. You put it in the oven, but you put a little bit too much sugar and it doesn't make the best pie. Right? So what I'm trying to say is that you could have all the ingredients, but if one little thing's off, you don't get the winter storm that you want. Or the storms set up constantly to your south and you keep on falling into the rain area, and everyone to the north, you would keep on getting snow. That could certainly happen. So we have to watch how each storm evolves, obviously. All right. So I want to say that just so that there's an understanding. You could have years where you have all the ingredients, but the storms just don't come together right. Okay. So just going to put that out there because that is the nature of meteorology, as we always deal with chaos. Okay. So just want to put that out there. But man, I haven't seen this good of a combination of features in quite some time. And so that takes us to our monthly forecast from the European guidance. And what I like to do with this model, guys, I tend to focus more on the 500 millibar heights than the temperatures and precipitation. You could use the temperatures and precipitation as kind of like a bit of a guideline, and I'll go over those as well. But when I see the evolution here from December to January, wow, that's impressive. Okay, so what this is telling me is that I have above normal heights over the Arctic and over northern Canada. So this is your negative Arctic oscillation, negative North Atlantic oscillation you're blocking. You have below normal heights to the south of that running across the mid latitudes. And you have basically what looks like a split pattern where you have a very active subtropical jet stream, a blocky polar jet stream, and the potential here for a lot of cyclogenesis, a lot of storm development. Even more impressive in February, Jesus, this signal is just off the charts here of impressive high latitude blocking. So everything here is lined up very nicely. If you're looking for a pattern to support winter storm potential, you can't get a better solution than what the model guidance is showing. I haven't seen better model guidance than this. Now, it doesn't mean this is going to verify 100%. But what I'm trying to say is that if I was going to look for a model guidance, if someone says, hey, Steve, draw a long-range projection, what it would look like as far as a stormy pattern, I would essentially draw this. So this is pretty impressive. Now, when we take a look at the 2-meter temperatures, this tells me here that, and we'll go back to December, above normal, makes sense. Look what we're dealing with right now, right? We're going to be heading towards, heck, on Sunday, we're going to be near 60 degrees. So this all makes sense. Again, you only need a few warm days to skew these temperatures a bit. In January, what does it say? Like some people were saying, hey, look, Steven, it's going to be above normal in January. Okay. What does that mean when you consider January average temperatures? And what is this really saying? This is really saying that, hey, there's going to be a lot of storms here, a lot of activity going on here. Depending on a storm track, you could get one storm track cutting up towards the Great Lakes. There's your above normal temperatures. The rest of them are along the coast. You average it out. There's your temperatures. So what I am very interested in is the precipitation anomalies here telling me Not necessarily, hey, we're going to definitely have above normal precipitation, but the storm tracks here appear to be focused along the coast and over the coastal waters. So you could see the trends here taking shape here. Stormy, active, storm track towards the coast. Plenty of high latitude blocking. Sure, you have a few warm days, skews your temperatures, skews your average temperatures, but there's also going to be plenty of days where it's near to slightly below normal. You get the timing worked out, and there's your winter storm potential. So over the next 15 days, we're going to see this evolution. You're going to see a lot of rumors of storms, especially past day 7 on this guidance, as all of this starts working out. And I'm showing you this guidance for one very particular reason. For the love of God, do not get wrapped up in the GFS past 300 hours. I guarantee you it's going to be showing blizzards and all sorts of crazy solutions after December 20th. The post-December 20th period, as we get closer to that, is going to definitely show a lot of insane model guidance. And the reason why is because it's working out all of these factors evolving. So don't get caught up in any of that just yet. Because when we're studying this pattern, what those models are essentially telling you in the long range, when you get past 240 hours, is basically that, hey, there's a lot of change going on. The pattern's going to slow down. There's going to be a lot of short waves to work with. Let's phase them all together and produce a massive blizzard on the East Coast. I guarantee you, you're going to see at least 3 or 4 runs like that as we move forward over the next 2 weeks. Don't get caught up in it. Don't get overly excited, and certainly don't post them on social media, although I know some people will, because it's going to disappear. And the reason why it's going to disappear is not that the pattern isn't favorable, it's just that the way that the model handles all these short waves moving around, they typically don't all phase into one huge upper level low. So just use some patience. But we're moving in the right direction. And you can see that very nicely here in the way that the pattern's evolving. Heights starting to build out here towards the Atlantic, shifting towards Greenland. Your polar vortex is starting to get displaced. Your heights begin to fall around the Aleutians. Again, this is about December 20th, 21st. This would put us at about the point when the MJO starts moving towards that phase 8 period. You see the support for convection around the date line, the shift in your trough. This drops south, this builds north, this gets forced south, and this heads up towards Greenland and Scandinavia. And as a result, we end up with basically that forecast. We end up with that. So we're seeing everything come together. This feature here would change into this here. So we're all moving in the right direction here. In the meantime, let's zoom in. We got some flurries to deal with. So we have this low pressure system exiting. We have this trough hanging back. We have the cold air in place, certainly. And you can see that at 925 millibars, at 850 millibars, we have short waves diving south in this cold air mass, and that's what's opening up the potential for these flurries. Nothing really impressive for tomorrow, but it'll look nice. Maybe a dusting here and there. Some of the flurries that formed this morning was due to this low pressure system in the subtropical jet stream getting stretched with the polar short wave trying to catch up to it. Of course, in the current pattern we are in, it's not going to be able to catch. As you can see on the polar jet stream, you have this positively tilted trough. Everything gets kicked out in the Atlantic. But you can see what the potential is. You can see what the potential is with this subtropical jet stream. If you get the blocking lined up, man, you could really create some very interesting weather. Just that right now we're not in that favorable pattern. But you could see already what that potential could produce as we developed quite a few of snow showers this morning just with that stretching in the atmosphere. So we have a lot of energetic short waves, a lot of potential out there. Now it's just a matter of whether we can convert that. In the meantime, we have a very concerning period of weather setting up for this weekend, specifically Sunday evening into Monday morning. Now, when I take a look at the upper level winds during this time period, the first thing that stands out to me is this signature right here. Let me pull in here. Okay, so see how the winds are kind of spreading out here, right? You're developing a lot of rising motion in the atmosphere. Rapidly rising motion in a warm atmosphere while you're getting strengthening 850 millibar jet. So what this tells me as we move towards Sunday evening and this trough starts to go into a negative tilt, look at this fanning that's taking shape here. You see how this is fanning out? This tells me a lot of air is rising very quickly. And that rising air is interacting with that jet streak. Those winds range anywhere between 70 and then eventually push to near 100 knots. Now that doesn't mean 100 knots is going to get mixed down to the surface. But when you see the combination of you have strong divergence and diffluence over this type of jet streak that is rapidly intensifying, this significantly increases the potential for very strong wind gusts. Notice also, we have this signature here. Winds crashing down. Off the Appalachians, very strong cold air transport on Monday morning. I wonder what that could be transporting. Well, let's take a look, shall we? Oh, well, a near Arctic air mass. What do you know? This is going to be a very tricky forecast, especially if you are in northeastern Pennsylvania and the Catskills, and maybe even portions of the Hudson River Valley. When we take a look at this setup here, you're going to have temperatures crashing from the 60s into the 30s. A good 40-degree drop easily in this setup. And we're going from plus 10 degrees Celsius to minus 10 degrees Celsius in a very short period of time over the northern mid-Atlantic. This is supporting very strong frontogenesis. So now you have two lifting factors. You have strong divergence and diffluence aloft. So think of it this way. You're stretching the atmosphere aloft above 500 millibars, right? So think of the atmosphere like taffy. So you're creating all these holes. The atmosphere has to stabilize itself, balance itself. So it's pulling air from the surface up to fill the holes in the atmosphere due to that stretching. That rising motion starts to create mixing in the atmosphere, where you have a strong jet streak running across the region at 850 millibars. So those strong winds are getting mixed down. Strong winds, strong frontogenesis, and oh, by the way, plenty of moisture to work with. You add all this together, and you can see this at 9 to 25 millibars, you have the potential here to produce heavy rainfall, thunderstorms, most likely low-cap thunderstorms, very strong winds getting mixed down within those thunderstorms. While that's happening, because of the negative tilt that's going on, you create what's called antifront precipitation behind the cold front. So that opens up the potential for snow. But there's only one problem here. When you take a look at this scenario, you see plenty of moisture. And the model guidance will say, hey, look, 850 millibars below freezing, 9 to 25 millibars below freezing. Clearly snow, throw in the snow forecast. There you go. Your snow map is made. Why? Because your snow map in the model guidance is 850 temperatures and precipitation. So 850 temperatures below zero, QPF, there's your snowfall amounts. If only if it was that easy. Because while this is evolving and while we have plenty of moisture, we also have very strong dynamic dry air transport, shutting the precipitation down. And also, while this certainly looks pretty impressive over northeastern Pennsylvania, there's also a matter of the ground temperatures. Now, we go from very warm to very cold in a short period of time. If we get strong lifting, that overwhelms the warm ground and you get snow accumulation. The only problem is that this low pressure system is pulling off to the northeast. I like that process more towards central and northern New York and New England than I do Florida, Pennsylvania. Now, is it possible? Absolutely. My point here is that I am very confident on the wind gusts, very confident on the heavy rainfall, not confident on the amount of snowfall behind this low. I could certainly see rain changing over to snow. I just don't know yet how fast it's able to start accumulating. It could be very fast. The factors I'm going to be looking for over the next 48 hours as we get better mesoscale data is how fast do the boundary layer temperatures, surface temperatures fall below freezing and at what rate? And at the same time, will we have strong lifting or PVA? Let me go back and show you the PVA here. So you see this strong lifting here with the front. This type of lifting here. If I get this hanging back a little bit more, then I have more strong lifting motion, rising motion in the atmosphere to couple with the surface frontogenesis, which would cool the atmosphere enough to support accumulating snowfall. So with this storm setup, I see torrential heavy downpours, about 1 to 2 inches of rain in about a 6-hour period. I see strong wind gusts. Let me just show you some of the wind gusts here. Again, mild produced, but you can kind of see what the potential here. You're talking about 40, 50, 60 mile per hour wind gusts on Monday morning. So certainly the potential here for power outages, wind damage, poor visibility. And of course, any old St. Nick might be flying into your next door neighbor's backyard if you don't secure it or bring it inside. We're bringing our stuff inside on Saturday just to be safe, because I don't think it would be good as new neighbors to have our decorations in our neighbor's front yard.
Yeah, I don't really want a polar bear projectile.
Yeah, true. We don't need any polar bears ending up in someone's window. So I would say definitely bring that stuff in, okay? Or secure it or something of that nature. Bring it in on Monday afternoon or Tuesday, better yet. You can bring it back out and set it up. But I would definitely use some caution with that. Bring anything that could lift off the ground into your garage or your house, because it is going to be pretty windy. And also on Monday, your high temperatures are essentially going to be when you're sleeping at 1, 2 a.m. Thereafter, in fact, let me see if I can pull up the surface temperatures here. Pull this up real fast. Do the 12Z instead. So there's your peak. 10 p.m., midnight. There's your high temperatures for the day. And just free falls from there. So yeah, your app is going to say 60 degrees. But the reality is that it's going to be nowhere near 60 degrees on Monday afternoon. It's going to be in the 40s and falling through into the 30s. So just be prepared for that as well. Combine that with the strong winds, it'll probably feel more like the upper 20s to lower 30s. So that is all the information I have. Now I am going to take all of your questions. And of course, we're going to start off with the premium chat and then go into YouTube and all that stuff. By the way, I upgraded today the 7-day forecast and made it more graphical. So that way, you have a little sun, you got snow, raindrop. I'm working to find something for ice. I haven't found that out yet, but I'll work on that. But you kind of get the idea that we're trying to go more graphic based. So we have a lot of questions in the live chat today. Very nice. And then, of course, we'll drop. Oh my God, and YouTube's really active too. Holy Badol, look at that. Wow. Whew. All right. So, and yes, I will answer sports questions. The answer is that the Mets should get everybody.
Oh, stop.
There it is. Let's see here. I think you should have pre-chat music. The other thing too is that if I do music, I have to find something generic because I'm pretty sure I'll get strikes on YouTube.
Free to
Yeah, I'll just get like one of those little horns that they had in the '80s and just start blowing on that. Drive everyone away. Let's see here. Looks like 10 millibar vortex already showing warm spots and stretching, but it's centered near Russia, while 70 millibars is also warming and getting stretched, but also more towards Europe and North America. Will orientation change as warming progresses? Absolutely. What you're going to see is stretching and splitting. If we get the major stratospheric warming and the wind reversal, you're essentially going to see the polar vortex blow up. Think of it like taking a hammer on a sheet of glass and then breaking it, right? Then you get these shattered pieces all over the place. So if we get to that point, that's essentially what's going to happen. And how that responds at 500 millibars is that you start to get all these above normal 500 millibar heights over Alaska, Siberia, the Arctic Circle, Greenland, and Scandinavia. And that leads to below normal heights over the mid-latitudes in a very stormy pattern with cold air trapped. So once we get to that point, the orientation of the polar vortex at 10 millibars becomes less of an issue. At 70 millibars, something we still have to watch. But if we get to that point of disruption, then we basically have a pattern that is very blocky. And then it's just a matter of studying the different short waves to see how they interact and phase and work together. All those winter forecasts based on strong east-based El Nino winter canceled look like they're going to be a huge bust, while your thoughts on the evolution of it are spot on, if not exceeding expectations. I always take long-range forecasting much like a baseball player. And what I mean by that is that some years you bat 270, you strike out a lot, and you hit a home run or two. And then other years you just see the ball really well, and you bat 315 and you win the batting title. You know, like Jeff McNeil, basically. So right now I'm having a very good Jeff McNeil year in terms of long-range forecasting. I'm very happy to see everything starting to fall into line. We'll see how that works out as we move it through the winter. We had one winter storm type scenario a couple weeks ago where the forecast worked out really nicely. So, we're going to keep an eye on it and make sure that we focus in and trying to focus in on the winter storms and make sure those forecasts are just as accurate or better. SBC Day 4 has 15% risk by the Gulf Coast of Louisiana and that part of the Southeast. Yeah, I would not be surprised if we get not your traditional severe thunderstorms up here, but severe like. I would not be surprised Monday at 1 a.m. if we have a severe thunderstorm warning. Because of the intense rainfall, you get some lightning and those wind gusts, the downburst wind gusts. I definitely would not be surprised by that. I see a lot of treadmill running in my future. Yeah, not much running outside, that's sure. Earth News Schools also shows warming at 70 millibars and 10 millibars. Yep, it is. It definitely is. So the observations are all there. Absolutely. Hockey axes. I saw this and was interested. Does this have any implication on the immediate or near-term or long-term effect of the atmosphere expected colder and stormier conditions? The giant hole, you're talking about the giant hole in the sun. That doesn't have an impact on our current weather, okay? It certainly has an impact on satellites, though. So if you're having any screwy issues with your TV, internet, your phone, that's why, because it's interrupting, interfering with a lot of our satellites. We're getting a lot of solar winds impacting the Earth, which impacts our our ionosphere, but not yet what would impact the stratosphere or the troposphere. We're kind of protected from that. What would impact our weather in the long run would be a reduction of sunspots leading to a quiet sun, which allows buildup of ozone, which creates a warmer on average stratospheric environment, which in turn leads to a on average weaker polar vortex. So when the stratosphere is very cold, the polar vortex gets very strong. When it's warm, as you know, it gets very weak. So if the base environment, because the sun's influence causes a warm stratosphere on average, then that causes a weaker polar vortex on average. With that, there's also factors to consider with CO2 and methane and how that impacts the chemistry of the stratosphere as well, which we have to always be aware of and keep that in the back of our minds and work that out as an evolution. But in terms of solar influences, that's primarily the impact. The fact that we have a rather impressive hole in the sun's atmosphere right now, that's not something that's unusual that happens from time to time. It sometimes is a sign of a shift in the polarity of the sun, which is a very important and natural factor that happens every 11 years or so. So that means we're getting towards the close of our solar maximum, which means we're seeing the peak of our sunspots, and now we're going to be heading in the other direction over the next 11 years. So I would say by the late 2020s or early 2030s, we'll be in a quiet sun phase. And then we'll be something like what we saw in the late 2000s and early 2010s, where we had a warmer stratospheric environment overall and greater disruption of the polar vortex. So we'll see how that all plays out as we move forward. This is all great, but what do you think could go wrong? Good question. Okay, so how do I describe this? All right, so you can have all of the factors together, the high latitude blocking, all that stuff, right? If you have one short wave that is negative tilt and the other is positive tilt and they don't interact properly, that could cause a storm not to phase and to counteract each other, okay? Shear each other apart. That could certainly be a factor. If the high latitude blocking sets up in such a way where it's more of an east-based negative NAO, then you got a storm cutting along the coast more. But based on the data that we're seeing, we're not seeing any indication of that. I think the best potential of something going wrong is if we get an Arctic air mass that's so strong that it suppresses a storm track to the south of us and we get cold and dry. Meanwhile, my parents in North Carolina who left New Jersey to get away from the snow would end up with all the snow and we'd end up with nothing. That I could see very well happening, which would be my luck. That is something that could certainly happen, where you get more winter storms down towards the southern mid-Atlantic and southeast, and the northern mid-Atlantic misses out. So we just end up cold and dry. That could certainly be something that could go wrong. So that's certainly something. But I would say again, unlike other past years, there's no sign of any type of stratospheric cooling, certainly. No sign of anything with the stratosphere or the polar vortex strengthening. No guidance to support that idea. The tropical forcing is moving in the right direction, both in observations and models. So if there's anything that would go wrong, it might be too much of a good thing. But we're not there yet. Any chance that the cold air masses are persistent enough to match the winter where we still got snow and ice with south and southeast winds? In this region, I'd have to see the actual air mass to make any type of positive statement with that. It's really, especially with above normal water temperatures off the East Coast, an easterly or southeasterly wind is going to drive in that warming. Now, here's where it would work out. If you're in northwestern New Jersey, the Poconos, the Lehigh Valley, the Hudson River Valley, these cold air masses are not going to leave very easily. And that could lead to some ice concerns. So I'll go with that, but I wouldn't do anything further than that, like the coast or anything. Our summer storms seem to drop so much rain due to the atmospheric warming. Will big snows drop more snow? Oh, that's a great question, Andrew. Okay. So one of the things I've always studied when it came to global warming was the precipitable water values. I've been saying this for about 15 years. Stop focusing on temperatures because there's too much other influences and factors that makes the data muddy, dirty, right? You got urban heat island effect. You have some poor observations from the past. You have questionable satellite data initially. But the one thing you can calculate and remove that data and remove that error in the data and to kind of clean it up is precipitable water values because it's a concrete and well-established equation based off of standards, atmospheric standards. So you can remove some of the noise and create a better understanding of what's going on in the atmosphere. Because what it does is that it gives you a better idea if the 500 millibar heights are expanding, it's able to hold more moisture. So if your precipitable water values are rising steadily and they're becoming more enhanced in the mid latitudes, the only thing that could cause that is overall global warming. Okay, a warming of the troposphere, expansion of the troposphere to allow more water vapor in the atmosphere, right? So you don't have to worry about whether or not there was a city being built or whether or not there was an airport next to a thermometer or anything of that nature. All that stuff can get worked out. You can flesh that out in the equations and you can create a more sanitized data set. So by creating a more sanitized data set, you can understand what exactly is going on. So we've clearly seen an increase in precipitable water values. We're seeing more and more frequency of precipitable water values pushing towards 2 inches and at times 3 inches. In the winter, closer to 1 inch. To give you an idea, in the 80s, we never really saw, except for maybe one storm, where precipitable water values pushed over 1 inch. Now we saw it a little bit more in 2009, 2010. And as we went through 2015 to 2016, we saw that even more show up. So what does that tell us? It's holding more moisture. So it leads to two factors to consider here. One, you got more moisture to work with. At the changeover points, it leads to a snow ratio that could be a little high. So like 8 to 1, 10 to 1, somewhere in that ballpark. So you end up with wetter snow. But if you're working with a true Arctic air mass and you got those enhanced precipitable water values, that's where you feed the fuel for the potential for impressive vertical gradients in the atmosphere, add in the urban heat island effect, and you end up with a explosive environment for convective snowfall, or as we call it, mesoscale banding. And this is how you end up with one town getting 10 inches of snow as a base and someone else getting 25 inches because of that convective environment. So yes, in short, yes, there's a lot of factors that go involved in that. Absolutely. It's going to be very interesting to study this winter. Any chance of flooding or flash flooding? Yes. There's going to be a chance Sunday night into Monday morning. Someone's going to get 2 inches of rain out of this, and the urban flooding is going to be an issue. I am far more concerned, though, about power outages being an issue with these strong winds. I would not be, especially around Monmouth County. It always forget about it. We're definitely going to see power outages out of this somewhere. Yeah, exactly. That's exactly why we got this generator. It's going to save us, and we'll be able to do our updates in the morning. But I'm telling you right now, this is going to be a very windy and stormy period of weather Sunday night and Monday morning. Yeah, it will come in basically like a large wall of rain. Non-weather note from a couple of people that Godzilla 0 Point is excellent. Yes. All right, well, I'm just going to say it here. If the Academy Awards does not give Godzilla -1 a Academy Award for Best Picture, then it's not worth watching that show. It's not really worth watching that show to begin with. But there is no reason. It's clearly the best movie in the past 10 years. I mean, it's better than Titanic. It's better than all of them. So instead of giving awards to movies where you already know the ending because the guy is dead, so whatever, Just give it to a movie where you have true artistry, which is Godzilla -1. Diamond shape for ice with the I just had to figure out how to add that together. Soto is going to the Yankees. It looks like. Yeah, you could have him. I'm sorry, I'm not impressed with that guy. You know what? I've seen him play with the Nationals. I've seen him play with San Diego. I'm not afraid of him. Go to the Yankees, have fun, and then you can rent him, and then the Mets will buy him next year. Let's see. I want to see a Ted Williams year. Yeah, I wish. This is a good example of low top, high shear type weather, severe weather, winter severe weather. Yes, this is a perfect example of that. And I'll tell you what, it's also a perfect example where you get this type of transport in the atmosphere. You're getting a lot of warm air surging northward in the mid-latitudes towards the higher latitudes. This translates or gets transported into the stratosphere, which starts to enhance our high latitude blocking process. So you need this cold front to kickstart this whole pattern. And that's essentially what we're seeing here. With the western lean of the tropical convection at the dateline, the PV disruption hopefully leading to high latitude blocking that feeds back on itself and leads to an eventful late December through March. That's generally the idea. Have you done any more research on the GraphCast AI model? There are other people that I follow, like Ryan Mao, that is studying this, and they're far better equipped in studying the little ins and outs of this AI data. I'm very interested to see how it plays out, because then I can beat it. That's all. Here's the thing. The AI models are great tools, but if you use it as a crystal ball, I guarantee you there's going to be blind spots. Because the minute it ingests poor data, it's not going to be able to handle it very well. Right now, these AI models are getting the top of the top, best of the best model data. It's getting the best observational data. When there's an error in that observational data, just how well does that model perform? And that's not a knock on the model. That's the case on all models. So, great tool. Looking forward to see how it works out. But as always with model guidance, it depends on the data that goes into it. If I was running things, so to speak, if I was running NCEP, my focus would not be on building more and more model guidance and more computers. I would be setting up to develop a strong mesonet for the entire country and getting the best observational data. Because if you enhance the quality of the data going into the model guidance, you're going to start getting better results, and then you could upgrade your schemes and your resolution, because then you have the data to go along with it. Even then, there's limitations. Let's see what we got on YouTube. Let's see. Holy smokes. This winter will be a record-breaking for... Let's see. Wow. Great discussion. Great job as usual. Love your discussions. Wow, there's just a ton here.
Yeah, you got something on Twitter, too.
Oh, wow. What a busy night. With the potential pattern that could happen, is it good for Central PA, like back towards State College? Well, this upcoming cold front, you certainly have some good potential. I would say in these type of winters, you get your storm track more focused towards the coast, so sometimes central Pennsylvania misses out, but that doesn't mean that it's always going to work out that way. And also, don't be surprised if you get some lake effect snow bands dropping down your way via an Arctic cold front, like a snow squall every so often with that. But that region's typically, when you're getting a lot of storm tracks focused towards the coast and the coastal waters, you kind of miss out on the heaviest snowfall. But you also tend to get more frequent snowfall events, but they're more like in the light to moderate range. My analog for winter is 1957-58, 65-66, and 77-78. Yeah, those aren't bad analogs to use. Remember, we're in a different environment. And also, some of those years don't have the same QBO. So I'd be careful with that. But I can understand why those years would be picked. Final analog 69, 70. Yeah, that's all right. 76, 77, 77, 78. If anything, I'd probably lean more into 2014, 15. But even that doesn't have perfect match. So I'm not one to really use analogs all that much, to be honest with you. I don't think it's a good practice because it's a different atmospheric environment. So it's not good to use that as a one-to-one comparison. You can use the analog process to understand the processes in the atmosphere and some of the signals, but I would not use it as a one-to-one type forecast tool or even as a basis for a forecast. I would use it as a way to look at the way the pattern evolved in those years, what were the factors that caused those changes, and then calibrate for the changes that we have in our sea surface temperatures and the state of the atmospheric or stratospheric winds. So I'd go all through that process. Yeah, this definitely has the potential for a squall line. I would not be surprised if we get a squall line with areas of snow behind the squall line in eastern Pennsylvania, and this just is a wall of very heavy rain, strong winds that's marching across the region. Tomorrow's snow showers won't be that bad, just kind of like a flurry here and there. A snow shower maybe produces a burst. You might get a dusting out of it, but that's about it. We definitely covered the strong winds. I could try writing a little music bed for you to use. Oh, wow, that'd be pretty cool. Thank you, Brian. That's from Brian Kelly. That's pretty cool. Like classic Weather Channel. Oh, yeah, the New Age stuff.
They used to use Moby.
Huh? They used to use Moby? Oh, man. I remember, yes. I remember having that music on, like at 1 a.m., right? And I'm like sitting up there and I'm trying to watch the snow. I'm like, 15, 16 years old. And my parents are like, why in the hell are you up that late? I'm like, I'm looking for the snowfall. It's supposed to start. My dad's like, you're sick. I'm going to bed. So they thought maybe I was sick or something, like I was like ill, like the flu or something like that. They're like, why is he up? And I'm sitting there with the Weather Channel on with like freaking the music playing, trying to look for a snowflake. That's when you really have it bad. How is the Giants game looking? I think the winds are going to be increasing. The rain looks like it's going to hold off, but definitely notice the winds are going to be increasing. Let's see. When should be our first snowstorm? Okay. The first snow potential. How about that? Let's go snow potential. The first favorable pattern for a winter storm is going to be, and don't hold me to this, right around Christmas. Yeah. That's when the pattern's going to start to align. So I am not calling for a white Christmas. I'm not doing that yet. What I am saying is that the pattern is going to be more favorable. I'm not sure what the coldest temperature in PA. I'm not sure about that. The snow showers, more like snow flurries, widespread. But even with that, main locations won't see it. What do we got on Twitter or X or whatever the heck they want to call it these days? As always, I'm just so everyone knows, I'm not leaving any of the social medias. I try to use as many as I can, but some of these social media companies gotta go because I can't cover all of them. There's a Blue Sky or something. I'm not even bothered with that one.
There's a lot out there. Okay, so
Yeah. What do we got?
JH609.
Okay.
Steve, huge southeast trend with the Sunday night storm over the past few days.
Mm-hmm.
Last year, everything went northwest west. Do you see this trend as a theme this year?
We can't call anything a theme yet until we establish the pattern. We're not in the winter storm pattern yet, so we can't assume the trend. What we can take from it is that the models are trying to adjust with the interaction between the polar and subtropical jet stream. So when we first talked about this storm, I said that storm track is going to be somewhere between the eastern Great Lakes and the coastal plain, but not the coastal waters. Why? Because of the nature of the trough, right, being positively tilted. So we know where the guard lines were. Now, in between those guardrails is the question of when do the short waves start to interact and phase together. We're seeing that phasing happening earlier in the model guidance, so you're seeing this trend more to the southeast. What we're basically seeing is that phasing interaction happening faster, the surface low pressure system intensifying earlier, and now cutting up through southeastern Pennsylvania and towards central New England. But there's a limit on how far east it could actually go because of the nature of the whole long wave trough. So you use the long wave trough as your guideline, your guardrails, right, of where your storm track is set up, and then you go from there. And then the determination of the actual storm track, in this case, the evolution of the surface low, will come down to when do these short waves interact and the intensification process begins. The faster that intensification process begins, the further east that low will go, because the cold air transport involved in this whole system with the negative tilt to the trough will force everything further east. But again, there's a limit in that evolution. So that's why we're seeing what we're seeing. But we can't call it a seasonal trend yet until we actually get into our seasonal pattern. Next question.
That's it. No.
That's it? Okay, there you go. Let's see here. Let's see. We got some good questions. Are precipitable water values high for Sunday night? Yes. That's why I'm looking at 1 to 2 inches in a very short period of time. The precipitable water values. Do I have that up here? Let me see if I have that in here. Here we are. Let me go back. Okay. So these precipitable water values, when you get up into this range here, this time of year, these are typically summer values, okay? So we have a ton of moisture surging northward. So this is the type of precipitable water values that you would see in a strong cold front in May, June, July, right? That's why it really stands out to me. So you're basically setting up the environment for just a wall of rain just marching across and convective weather. Better data over the Pacific, Atlantic, and polar areas would be a big plus as well. Absolutely. And we're getting there. We're definitely improving. What areas have the best chance for thunderstorms on Sunday? Usually the Delaware, I would say the Delaware River Valley to the coastal plain. Because that's where your temperatures are really going to spike at the surface to 850 millibars to around 10 degrees Celsius. But really the whole region has that threat. You know, anywhere where you're going to get that frontal genesis really playing out along that frontal boundary is going to feature those thunderstorms. And look at that. It's already 9 o'clock. Wow.
Time flies when you're having fun.
That is true. Well, this was a great chat. I do want to let you guys know, and here, let me pull this up real fast. I put in the dates of when to expect our live chat. So let me pull that up here real fast, just so everyone knows what the plans are. Definitely straight line winds will be a threat. Absolutely. So premium members, as you know, when you go into the dashboard, what I'm going to start doing is putting the live chat schedule up here, right? So obviously tonight we had our live chat. The next one's going to be on the 12th, which is a Tuesday. And then the final one for December right now is the 20th. Now, between Christmas and New Year's, I usually take a break. Obviously, if there's a storm I will have a live chat and live coverage, and we'll take everything going on. But if there isn't a storm, then I'll likely take that week off to spend time with my family and my wife and stuff. We celebrate Christmas and all that good stuff. So that's the plan right now. Of course, again, like I said, during that Christmas week between Christmas and New Year's, if there's a storm, obviously I will have a live chat and we will be having a lot to discuss. So that is the plan going forward. In the meantime, I think we're going to call it a night. Some outstanding questions. I really appreciate it. As always, thank you for joining. It really makes a difference. If you haven't already, please like the page on YouTube. It actually helps a lot and gets the word out. Let your friends and family know where you get your favorite weather data from. It actually helps the channel. And of course, if you are not a premium member, please consider in subscribing. Only about $15 a month. And I think you would agree that's well worth it because you get this every day. There you go. Not bad, right? So in the meantime, have a wonderful night. And as always, stay safe out there.